Hello. So far in this prototyping series, we have talked about what prototype is, why you often need more than one, and why prototyping is so important in any development process. But how would you actually build one? What tools and methods do we use? That's what we are diving into today. When we are working on any new hardware or IoT development product, one of the first things we decide is how we're going to prototype. And the answer really depends on what we are trying to test. So let's say we're trying to test size, fit, or form of a product. So we might start with something really basic like foam modeling or 3D printing using PLA or PET. Or yes, if you're using FDM, or there are other methods of 3D printing like SLS and SLA and others. These are quick to make and help us figure out how a product will sit in your hand or fit in a space. But if we are testing how the product functions, we'll use different methods. For electronics, we often start with off-the-shelf boards like Arduino or Raspberry Pi or similar to simulate the behavior we after. These boards are a great starting point because we don't need to design them, and the board and the whole prototype will be very fast to work with. It's modular, cost-effective, because we don't need a custom PCB design yet. But when we get a bit more confident with the concept design, then we move into more complex processes. In these cases, we might use, for example, other methods like CNC machining, laser cutting, vacuum casting to get higher quality parts. And for electronics, we might start with designing our own PCBs to fine-tuning the performance and reducing the size. Sometimes even we mix and match, 3D printed housing with hand-soldered electronics inside, because in early stage, what matters is learning, not perfection. It's important to keep in mind that our design details in all of these processes is completely different from each step to another, as each rapid prototyping process has its own limitations and requirements. A design that we have used for 3D printing won't be suitable for CNC machining or later on for injection molding, for example, and vice versa. So it's important to have a plan, as in what we want to build, why we want to build it, what we're going to test. The big things I want to stress here is that prototyping isn't about showing off a polished product. It's about asking the right question and then choosing the fastest and most cost-effective way to answer it. We at CRINNAC use all of these different rapid prototyping methods, from 3D printing off the shelf to custom design board, vacuum casting, CNC machining, and so on. Even cardboard, if that's what it takes to learn something useful. In the next episode of this series, we will talk about some of the most common mistakes we see in prototyping and how to avoid them. But for now, if you are starting out any new projects and wondering how to prototype it, start small, think fast, but don't worry if it looks a bit rough. That's the whole point. See you.